Hi everyone, how are you doing? Yeah, okay. Enjoying the conference so far? Yeah? Okay. I know it's a bit hard after lunch, but I will try to keep this entertaining. So today I will talk about, and I just realized it's a pretty long title, but harmonizing your platform domain with Kubernetes and custom resource definitions, okay? It will become clear in a few seconds. Let's go. That's funny, this thing is sliding down, but I can see the time. A few words about myself, and then we will dive into the meat of this talk. So I'm Sebi. I'm half French, half Dutch. That's why I have this weird accent. I'm a Java developer. Sorry for that. I won't show any Java code today. I'm a developer advocate. So my job is to make developers happy. And that's what I will try to do this afternoon. I'm currently a developer relation engineer at Port, we are an agentic engineering platform. If you don't know, we know what it is. Come to the booth, have a discussion with us. I have another slide about that later. And beside that, I love the game Half-Life. It's the best game ever. And I love cats. I have 5 cats, 2 kids, 1 wife. Let's go. Okay, so we need to talk a bit about platform engineering, okay? And we could spend the whole day trying to find a good definition of what exactly is platform engineering. Because I have only 28 minutes left, I decided to keep it short. Platform engineering is about empowering developers. And developers is a bit restrictive. It could be anyone consuming your platform. Okay, it could be your SREs, your managers, your CTOs, okay? But still, empowering developers, what does that really mean? Because that sounds really nice, really powerful, empowering developers. But concretely, what does that mean? Well, there's one really important thing. Implementing platform engineering in your organization is about absorbing the cognitive load of developers. When I started as a developer in 2004, I was a Java developer, and the only thing I had to care about was writing my Java classes and committing that to CVS. Yes, that was still a thing. And yeah, and then it was going in production once a year on WebSphere, and that was okay. But since then, developers have to know so many things. They have so much cognitive load. They have to learn maybe a bit how containers work, how maybe kubectl works, maybe they're doing some Argo CD stuff, and maybe they have some security shift left, so that they also have to care about. So a lot of cognitive load was thrown at developers, okay? And platform engineering is about absorbing this cognitive load for developers. But that's the thing. Absorbing cognitive load doesn't mean that the cognitive load disappears. It just moves from the developers to the platform team, okay? That's really important. 3 weeks ago, I was at FastFlowCon in London, really cool conference, and there was a keynote by Raquel Wanacott, and it was about cognitive load. And I love this slide. It says, cognitive load cannot be destroyed, but it can be designed, okay? And that resonates with me, because what I'm going to show you, the way how you design your domain model for your platform, it's, in fact, designing your cognitive load. So look it up. I think the talk is available on YouTube. This conference, FastFlowCon, just quickly, a few notes about that. It's a conference based on this book, Team Topology. So if you are into platform engineering, I guess you have read the book. Who has read this book just by... Nice, cool. So if you want to be able to distribute your cognitive load, you also have to see how you organize your teams, your team topology, okay? That's not the topic about this talk, but I just wanted to mention it because it was a keynote based on this book. Okay, let's continue. So how do we absorb cognitive load from developers when we do platform engineering? First of all, we will try as much as possible to offer them self-service. Okay, that is also to absorb the cognitive load of the ops team. If I need an access to a managed database, I need a new, I don't know, developer environment. I want something easy for my developers where they feel that they have the self-service. In the same time, I'm sure I'm streamlining exactly what they can or cannot do, okay? But that is one of the first pillars. The second one is providing an harmonized platform domain model. Platform engineering is about bringing stuff together that doesn't belong together in the real world, but which makes sense for you in a platform. I don't know, maybe a Kubernetes deployment. It has a label that matches maybe a Jira project, and it makes sense for your platform, for your developers to have this view consolidated, okay? So that's the other really important thing about platform engineering. So again, I mentioned great stuff there, self-service, harmonized platform domain, but concretely, what does it mean if you do platform engineering? Well, you probably want to build an internal developer platform. And again, we could spend the whole day on this, discussing what are the best practices. I just want to mention a few here. And first of all, you have to choose a base platform, okay? And that's really up to you. I have my opinionated view on this, and you will see it in a few seconds. But anything could be your base platform. For some people, GitLab is their base platform. And maybe they will build some actions, some GitLab pipelines around it, and that's their base platform, okay? Or you build your homemade base platform. I don't advise you to do that, but yeah, that's things that we see. When it comes to IDPs, and you have to pick a base platform, and yeah, we are here at KubeCon, I think it should always be Kubernetes, okay? And I will come back on that on a few seconds. Base platform should be Kubernetes. Then you have to choose how you are going to build your IDP. You can stay generic. That means you can pick, for instance, Kubernetes and just a vanilla Kubernetes instance, and that's your platform, okay? Really generic. Quality of experience for developers, not that great. You can go completely the other way, restrictive, where you end up almost being a container as a service or source code as a service, where you can choose maybe the ports, some replicas, and you just provide an image and it gets deployed, okay? Really restrictive, maybe that's not the best option for an internal developer portal. Or you can go in the middle, opinionated. So you have opinionated views on how things should happen, but at any point, a developer can deviate from this route, okay? That's really important. Otherwise, you will start having shadow IT and stuff like that. Fruit salad or fruit basket, and you wonder, why is he showing this? That is also, when it comes to self-service, you can grab a few operators from SaaS vendors that make sense for your internal developer platform, like providing a new managed database, and you can just put it as it is on top of your platform, okay? And that is a fruit basket. Or you can try to really think about how you can streamline exactly what you want to provide to your developers. And in this case, you will create fruit salads, okay? Might sound a bit abstract, but let's sink that in, and maybe tomorrow it will make sense for you, or even later today. And that is the most important slide of this presentation. Treat your platform as a product, okay? That's the most important thing in platform engineering. And since it's a product, it has a well-defined domain model, which represents your platform. And that means you need to find a way how you can persist, how you can declare the desired state of this domain, the domain model platform, okay? And let's back to the base platform. That's the hat I'm wearing now. I was so happy yesterday when I bought it. I said, hey, let me put that on the slide. So why Kubernetes as a base platform? Well, let's really go quickly over that. Kubernetes is about defining a desired state, okay, that you express in resources. And Kubernetes will make sure that the reality matches your desired state. Quite simple, but one of the most powerful things. And of course, you can do that for the native resources, but you can also extend Kubernetes. And that is why I think Kubernetes should always be your base platform for building IDPs. My preferred pattern in the Kubernetes world is the operator pattern. Okay? Basically, you can define your own resources, and it will benefit from the whole power of your Kubernetes cluster. And you couple that with a controller, and the controller, what the controller does is completely up to you. It's your controller. You do whatever you want. Of course, there are some best practices, but that is really, really, really powerful, and you will see that in a few seconds. So operator pattern is I have a custom resource definition, and I have a controller associated to it. You will also see we can just define a CRD and have the control part completely outside of Kubernetes. That is also something which could make sense for your organization. But I want to focus a bit on CRDs. Okay, so CRDs, what is it? It's a resource. Okay, so first of all, it's like any other resource, like any other manifest that you will handle. It will be persisted in ATC2. You will have the get, the list, the describe functions. So it's a Kubernetes resource, and that means you can also persist it in a Git repo. You can adopt the whole GitOps flow around it. So yeah, it's just a resource where you define a desired state, a custom desired state, which makes sense for your platform. Okay, so we have the native Kubernetes resources, but of course, with CRDs, you can define a new kind, a custom definition. Okay, you just define a new kind. Sometimes I show that to people. I define the kind pizza, and then we can persist pizzas in Kubernetes, and it don't really make sense. I have a bit better examples here. Again, you extend Kubernetes. Let's see quickly what a CRD looks like. Okay, so you will define like any other Kubernetes resources an API version, the kind. Okay, you have some metadata, and then you have the spec. What is a spec? That's an interesting part. In fact, it's just an open API schema. Okay, so there you can just express exactly what you want. It could be a rack pipeline request. It could be a service, which is an abstraction that covers other things. Okay, you define really whatever you want, and then it's open API, so you can here you can define enums, you can have restrictions. Oh wait, that's the one. Sorry. So you benefit out of the box of all those things. You have a few field types, okay, string, integer, Boolean. You can put some constraints. You can put some validation, and that's really nice, okay. But if you want to represent your whole platform domain model with CRDs, you might also have to express some relationships between different custom resources, okay? So let's just quickly mention the few options that you have to express those relationships. And again, it's not really in the scope of this talk, but, and I'm so proud of this picture. I just added you the prompt that I used. Relationships, friendly, cartoon style. And he came just with this giraffe that seems so happy, and everyone is so happy. I love it. Okay, so I say, oh, why not? Let's use that. It's with Gemini. Okay, so how can you design relationships between CRs? So you have a lot of options. It's really flexible. In your custom resource, you can do just a direct reference by name. Okay. You just say, hey, if this service need maybe a link to a Jira project, it will be Jira ref, something like that, and you just put a name, and then it will be up to your controller to validate that and to retrieve and inject, if needed, the content of this reference. Object reference, where you can be a bit more flexible, you can define what kind of types could be linked. Owner reference, this one is pretty cool because that is a native feature of Kubernetes. You can set some owner references, and if your custom resource creates, for instance, I don't know, deployments, some services like that, if you destroy the custom resource, all the underlying child will also be destroyed. Okay, so that's a good one. Or the famous one that you are really used to, like when you define a service and you define the service, the selector for selecting the pods. You can also use that. That is more if you need to have lists, many to one, many to many. So a lot of options. Again, you can express relationships. You can also keep it completely plain and decide to handle the relationship somewhere else. Okay. Again, it's just the idea is to have some kind of single point of truth, okay, for defining your platform domain model. And I think CRDs is a good one. And then you, of course, once you get your CRD, your controller, you benefit from the reconcile loop, and that's really great. If something is drifting compared to your desired state, Kubernetes will just make sure to reconcile that, okay? So you can start building your operators, expressing in CRDs what your platform domain model looks like. It's really, really powerful. I think, yeah. And just to finish before, and then I will do some demo. Yeah, I'm super good in the timing. A lot of people think that when you create an operator, they think that your controller, based on the CR it will receive, do things only inside Kubernetes. Maybe creating deployments, config maps, I don't know. That's true, that can be possible, but again, a custom controller is just a pod. It's your pod. And in your pod, you do whatever you want, okay? And if you need to make some external API calls, you can do it. In my previous company where I was working, Ivan, they didn't do anything with Kubernetes, but still they were providing an operator so that people could use the entry point of custom resources, applying custom resource on the cluster, and that will maybe on the Ivan side create a Kafka, create a Postgres, okay? So again, it's your pod, you do whatever you want in the pod, and that's really important. So it can be a central entry point. So concretely, what does it mean? I decided to show you a short example of something that you want to have control over in your platform team is the prompts, okay? Everyone was joking about prompt engineering 2 years ago. I was the first one to make jokes about it, but no, prompt engineering is a real thing. Well, now we say context engineering. But anyway, instruction prompts, stuff like that, that is something that you want to have in your platform and that you can streamline to your developers. So when your developers start a new project, they can select, based on the projects they are on, a set of defined prompts, okay? And I say, so, okay, let's try out, let's represent a prompt like a CRD. And let me go in demo mode. Okay, so I got here a Minikube running locally, and I have quite a lot of CRDs if I do. How's the font? Do you want me to increase the font? A bit, yeah? Like this? Yeah? Okay, yeah. Even for me it's better. Yeah, you know, I'm not that young anymore. You can see a lot of CRDs here, but if you take a look here, you can see, hey, prompts.mcp.io. So that is a prompt, that is a CRD that I created a few months ago. So if I do a kubectl get CRD, this one, I want it in YAML, for instance, okay? If we take a look here, so it's a custom resource definition. You can see it here. Oh, where is my mouse? There it is. It's a custom resource definition, okay? That's boring stuff. And here I want to show you the properties. So I based this, it's based on the MCP spec of prompt, because MCP is not only about tools, you can also define prompts in MCP. So I took this definition and I added some stuff. So you have arguments that you can pass to your prompt template. So you can define a prompt template. You can define a description. You have an owner. That is something that doesn't exist in the MCP spec for valid reasons. And they don't also have status. But since I'm in charge, I do whatever I want with my CRDs. I decided to enrich my prompt definition with those fields. Description, and then I can pass arguments to the prompt. Okay, so that's a CR. What will CR look like for a prompt? So I got one here. There it is. So for instance, that is a custom resource of the kind prompt, which is called the code review prompt, and the description, a prompt template for conducting code review with AI assistance. And then you can define here your prompt, the arguments that goes in. And that is a valid resource now for Kubernetes. If I do kubectl get prompt, you can see all my prompts here. My prompts are living in my Kubernetes cluster because it's my base platform. You can see here, this morning really early, thanks to the jet lag, I did some tests. KubeCon test. It's not a contest, it's the KubeCon test. Yeah, anyway. I just realized the KubeCon test. That sounds really cool. Anyway, so let's create one. Let's apply one and see how it goes. So I could do VI and create a new prompt, and I would be really proud because I can exit VI, okay? But let me show you just another way. Of course, you can use any portal, any custom things you have. Of course, I'm going to show just how we integrate with port. What I have here is a self-service action. So I mentioned about self-service action, and I have something here called create prompt. And that is based on my CRD. That means my CRD is living in my Kubernetes cluster, but my portal is capable of scanning this CRD and scaffold for me this form, okay? And it will keep it in sync. So I will change my CRD, this form will change, okay? I don't want to expand too much on that because it's not the point here, but my super live cool prompt during KubeCon, maybe a bit too long, no? Let's keep it like this. Okay, template, I am the best agent ever, okay? Worst prompt ever, but we don't really care. A live demo prompt. Okay, there we go. Demo, yeah. Status, it's experimental, and it's part of the example team. That's the team I'm part of, okay? And here I'm going to do execute. What will happen under the hood? It will just create a GitHub action that will create a CR based on those values. It will just create a CR and a pull request. So let me execute that. Let me cross fingers that the demo guys are with me. So it's in progress. I should have the job link in a few seconds. That gives me the opportunity to drink some water. Yeah, we have the job link there. Awesome, cool. So it's opening a PR for me. And now, GitHub, don't let me down. There we go. I got a pull request. Let's take a look. Open now by GitHub action. Okay, and if I take a look here, I can see that is really what I just defined in my form, okay? My super live cool prompt. And I can review it, we can comment on it, okay? But let's say, hey, I'm really happy with that. Let me merge this pull request. So I merge it. Always dream to do that. Looks good to me. Looks good to me. Or not? Okay, it's merged. What will happen now? Well, normally on my cluster I have also Argo CD listening to this repo. So in a few seconds, and let me refresh. Oh, look, I think it's already there. My super live cool prompt. Okay, looks like it's there. Let's take a look here if it has been. If I do a kubectl get prompt, there we go. And we have our super live cool prompt 15 seconds ago. Okay, so it's living there. That's awesome. That's cool. Super cool. I'm so happy. Let me see if I can find it back in my portal. If I go here, and if I go to my catalog, and I look for my prompts. Okay. I have a lot of prompts there. My super nice prompt a few seconds ago. There it is. So it's also in my portal. Okay, so I can also manage it from there. Something went wrong, you didn't see that. Okay, and let me just add you, and then I have 5 minutes. That's awesome. I can add. Let me just show you one, how do you call it? La cerise sur le gâteau, the cherry on the cake. Okay, we added a prompt in our Kubernetes cluster with a CR. It has been ingested by this portal, and port, by default, any entity of the type prompt will also be feeded. We have an MCP server, of course, like anyone. It will feed our MCP server with this prompt. So if I go here to cursor and I just turn it off and turn it on again, don't ask me to connect. Oh, okay. He asked me to connect. So you will see that live. Should be, Yeah, I hope it's my good account. Yeah, open cursor, there we go. Okay, so that is cursor connected to the port MTP server, and if I do backslash, I think it's this one, my super cool prompt. You can see I do a lot of demos here, but I think the one we use was my super cool. So my prompt is already available if I want in my IDE. That's another approach. You can stay in your IDE if you don't want to go to a portal or something like that. With MTP, you just can stay in your IDE. Awesome, cool. Let me go back quickly to slides. No, there we go. So you will write your operators, you will create your CRDs, that's super great, but at one point you might end up with a lot of different CRDs, a lot of different operators, not only your own operators, but also operators, vendors' operators. And if you want to offer self-service to your developers, you don't really want maybe to expose a SaaS vendor operator CR, because there's too many things that you can do there. So you want to abstract to create a facade. There are different ways of solving that. You can create an operator that operates operators. Okay, that's totally valid. But you have some other solution. Beware of the operator sprawl. Yeah. One solution that I always mention, because they are also friends and their product is awesome, and they also have a booth here, are my friends from Syntasso. They have a product called Kratos.io where you can compose your operators. Okay, if you know that you need a lot of operators, but you want a single custom resource for the developer, that's the way to go. You define a promise, they call that, a promise. And then you have this concept of pipelines, and that can, you can just declare the dependencies that you have on other operators. Go on their booth, they will give you a demo. I can give you a really quick example of that. If I do kubectl get promises, I got one here called rack pipeline, this one. So imagine you want to offer a self-service to your developers so they can, let me describe the promise called rack pipeline. You want to offer a self-service, a form where developers can request a rack pipeline. So they need a vector database, they need some good practices, the chunking method and stuff like that. You can express all of this in a CR, in a CRD, okay? Chunking config, stuff like that. And under that, maybe there will be several operators that will be called, but for the user, it's just a simple CR. And again, of course, you can expose that on your portal. So if I go back here to my self-service sections, I can do something like that. Okay, and oh, that's funny. I put all the fields on invisible, but it's synced, so it reconciled. Desired state, but here I can choose my embedding model and stuff like that. So you can go pretty far in defining self-service requests with CRDs. Discord change. I got 1 minute left. That's cool. That's cool. So if you end up doing that, creating maybe your own operators that operate other operators, or going the Kratos way, or maybe both, you should end up having a way more simple architecture like that. And here you may see a lot of different platforms, because the funny thing with platform engineering is when I discuss with big organizations and say, hey, do you have an IDP? They say yes. And do people use it? Well, that other team has also made an IDP, and that other team has also made an IDP, and that's the reality. You will never have just one single IDP. You will have a lot of IDPs. So have just another IDP to govern all those IDPs. And that leaves me a few seconds left. I think it will be a bit short to take questions, but please, I'm here until tomorrow in the end. I will be on the booth, so please come on the booth. Have a chat with me or my colleagues. It's on booth 430. My job is to make developers happy. My company's job is to make developers happy. If you want to answer this survey, that will help us, and that will help the whole developers community. Please come on the booth. We have a demo in 45 minutes. So if you want to see a demo more specific about the product, okay, come on the booth. And I'm done. Thank you so much, everyone.